we have Kristen Thyng coming today to give a tutorial on visualization. And Kristen is working at Axiom Data Science. She can tell a few words about that to share with you. And the tutorial will focus on visualization, and we're actually looking for a person to give a little bit conceptual understanding of how to make visualization as opposed to a specific library. So we're very glad to have Kristen, because it turns out that she has been developing one of the packages for color maps. So she can tell us a lot about that too. So go ahead.
Okay, yeah, so I'm Kristen Thyng. I work at Axiom, like Aiden. Let's see here. I'll just start with me here. So I went to University of Washington for my PhD, but in mechanical engineering. But my research was oceanography based. I was running an ocean model for tidal turbine sighting. So for my postdoc, I went into an oceanography program at Texas A&M, and I ended up staying there in Texas until June. I just moved back here, and I worked at A&M for 9 years or so, and I worked in particular funding coming from the Deepwater Horizon oil spill. So I was doing a lot of particle tracking for understanding the physics, since that would control where the oil goes. And then, that's how I got involved in the scientific Python community. There's a SciPy conference every year that's pretty cool. And it used to be in Austin, so it used to be really easy for me to go to. But anyway, in 2021, I went to Axiom, and I do similar work now, but instead of for my own science, it's for maybe other people's science or like management purposes or other projects that come up. And you can find me on GitHub. I'm only really here kind of right now, but I'm planning to go to the social this evening, but feel free to reach out to me on the Slack or just other means. Okay, so we're doing a visualization tutorial. The notebook is in the fisheries Jupyter Hub. No, this one?
Yeah, it's in the tutorial repo that we pulled a couple times, and it has not changed. But I haven't learned anything.
I didn't change anything because I was like, I don't want to mess with that.
You all should folder.
Okay, that's over here, so that's not in my eye. So like,
Yeah.
We can move the whole thing.
Oh yeah, okay. Kind of just
Being dazzled.
yeah. Okay, so I have some learning objectives here. Yeah. I'm gonna go a little more. Good idea. Okay. Whew. Got a like bright spot in my vision. Okay, so like Valentina said, my goal is to have this be more of a like guiding principle kind of tutorial rather than how to use specific software. But I will use mostly Matplotlib because that is what I know the best. So I have some learning objectives here you can take a look at. I don't intend people to have plotting experience, but to give people a chance to think about what you should think about when you're making a plot and try to like think critically about your plots. And I would recommend that you follow along kind of where I am, because otherwise it'll just be a little boring for you. We'll try to have some discussions along the way, and if you just read ahead, it'll be kind of boring. But everything is there, so you don't feel like you have to take notes or anything. Okay. Okay. So I'm going to just start with the simplest, the line plot. It's simple, but you should do a good job on it. So I have some data that I found with a Google search, and it's CTD data taken in Lake Washington this month. For all of the data, you can get it on the internet yourself, but instead of linking directly to that, we have it locally. So that's where the URLs go to. But yeah, just comment this out if you wanted to run this kind of normally. Okay, and I've done a little bit of rearranging. This is read into a pandas data frame. The details aren't important unless you're interested in that. Do a little rearranging just to get it so we can like use the numbers in a straightforward way. Okay, so here's a plot. I did have to move this. That is different in your notebook. My version was different, I think. Okay, so here's a plot. Oops. Now it's a little, I'm gonna make this a little smaller. So I'm wondering how we could improve this plot. And I'm looking for volunteers. What might you change about this plot if it was yours or you were looking to criticize somebody else's plot? Yeah. What about the axes? Labels, yes. Yeah, what is even being plotted here? It is salinity, but you wouldn't know that, would you? Yeah. Okay, yeah. Title, yeah. Plotted regression instead, okay. You're into statistics.
What are the color, what do the different colors?
That's also a good question.
It's pretty noisy.
Mhm.
And with the two solid lines, you can't see a lot of what's going on with the blue line. So,
Yep, I agree. They're kind of overlapping and annoying to look at a little bit. Okay. Some of it you can't fix because it's the data, but yeah,
Weird.
Yeah. go ahead. Mm-hmm. Mm-hmm. Yeah, that's a good point. Okay, yeah, so agree with all those points. In fact, why don't we, here, did I copy it? Yeah, I did. Okay, so we could add, let's see, the Y label. I'm actually not sure if this. Just gonna. Oh, that's right. I ran it all the way through. And I used the same variable. No, how did that already? Okay. I have to guess on some of the names, but yeah, we got our Y label in, get our title, salinity, like Washington, or maybe a specific location. Let's see, a legend, right? So we could say, let's see, that's one. And oops. Okay. So that gets to some of the labeling. The lines still look bad. Any ideas for how to improve the lines? What is your name? Sorry. No, you two spoke. Yes. Sorry.
yes, Maddie.
Maddie,
Um,
well, do you have an idea for how to improve the lines?
yeah, totally. I mean, you could go either set your alpha value or make them more transparent. You could go with just the data points and then kind of put a smoothing
Oh, wait, yeah.
regression fit.
The data point, okay,
Things like this.
yeah. So you could maybe change one. You'd maybe have to turn off the line too.
Yeah, something like that. And then I think in that case, like a trend line could be helpful.
Mm.
And then kind of, full capacity.
Mhm.
So you can kind of see both lines.
Mhm. I'm not gonna try to do that on the fly. Yeah. Okay, I'm going to scroll to some of my thoughts about it, which I totally agree with you guys. So lines and labels and titles, units are good. Thinking about the font size, I don't think it's too bad here. But if you were gonna have a big presentation room or poster, I don't know, I always kind of default to something bigger just in case. And here are two things that you may not hear a lot, but so there's this guy, Edward Tufte. He's famous for having books on how to make good plots. And he says to aim for 45 degrees for your line steepness. It's not so different from that, but you can change that by changing the figure size. And I just wanted to let you guys know about that. And then chart junk, like get rid of it if it's not necessary or change it. I think this grid is too much. I find it overpowering, like Maddie. Here's how I changed this plot, which a lot of the stuff is similar to what you said for in terms of axes properties. Maybe you don't need to say salinity so many times, but you get the idea. And then another side of things, line properties. So this is where you get into making it easier to see data if it's on top of each other, things like that. So this is one way to change it, to try to account for that. Maybe you like different colors better, or you want them to be printable in black and white. That these are both, I think, different tone and a different line style now. So if you print this in black and white, you'd be able to tell the difference. Yeah. See if I changed other stuff. I think I changed the font size too, just to demonstrate how to do that. So yeah, in summary, always include whatever metadata for your plot is necessary for people to know what's happening, labels, legends, etc. And make it easily visible. Just kind of take a minute to think about different people and different situations that will be using or looking at your plot. Okay. This came up a little bit. Yeah. Yeah, chart junk. I mean, my demonstration in this plot was the dark grid. To me, it's too heavy. I like grids often, but I would just make the line thinner. It looks like that didn't make it to thought I had that in there, but oh, that's right. I think it's right here. Here I turned it off, but here I made it a little less intense, and I personally like that. There's another package that there are different ways of turning on a grid that's just kind of more subtle, and I prefer that personally. So chart junk is anything that's kind of either distracting the viewer from the data, the important stuff, or even blocking it, perhaps. Yeah, you want it to be as intuitive as possible. Okay, scrolling ahead. So the next section, I'm talking about property plots. 2, 3, or 4 variables is what I'll talk about. So just like be thinking about data sets that you're interested in, maybe, and which of these might apply. So the 2 variable case is if you're thinking property, and this kind of came up in terms of should you use a line or a marker to plot. I tend to use a line if it's like with depth or with time, a property versus kind of a coordinate or something like that. But if I'm doing 2 properties versus each other, then I would use a marker. I think that's kind of a personal preference thing, though. But here I'm even calling it a scatter plot, which then assumes that you're using markers, not lines between the data points.
So you can like all the matplotlib method as time.
All of this.
You say kind scatter, that's like it'll be scatter.
All of this is wrapped. Yeah, it's all.
Okay.
I'm plotting direct. I am happy to talk about the specifics of the code also. This is all wrapped into pandas for plotting, and it's all matplotlib. Yeah. So this would normally take, several lines of code if you were plotting directly with matplotlib. And same with Xarray when we get to that. So yeah, this is the same data set. Let's say you want to look at, do a TS diagram of temperature, salinity, and see the relationship. So this is how you can do that. Pretty straightforward. But think about how you can expand this. Say you also want to look at the relationship with other variables. So how do the temperature and salinity vary with depth? You can add that in. Now I have the size of the markers going with depth. Not my favorite plot. But these are, and I added edge lines because, or edge width to try to differentiate. So otherwise it was just a big blue blob down here. Can someone see something wrong with this? Or something lacking in this plot? Jim, yeah, caught that when I was going through it this morning. Yes, that it'll be in the next example, but it should have been here too. So yeah, this, so we can see the relationship of these two with depth. So who knows right now whether the little ones or the big ones are deeper. So for variables, let's say you want to have, let's see, what do I add in? Dissolved oxygen to see how it co-varies. And so here we have it. And I did add a legend there for depth, and then color is covered by the color map. Unless I have missed it, it's not super straightforward to make, well, this is actually relatively straightforward, but ChatGPT is pretty helpful. I don't know what if there's a specific thought about AI assist encoding, but it can really speed stuff up sometimes. So I did, I think, just get this from ChatGPT instead of researching for it myself. I have made it by hand in the past, and it was painful. So anyway, so the point is here for this section, if you're plotting multiple variables together, you can use these plots together. Yeah, make sure to use a legend. Okay, I'm going to touch briefly on gridded plots. These things will kind of come back up as we go through some of the stuff in the later bit of the tutorial. Oh, and be thinking of plots that you want to make or have made that we can talk about if you want with some time at the end. Okay, so gridded plots, this is plotting from gridded data. So before we just had columns of variables with rows of observations, but gridded data is data or model output that varies with two coordinates simultaneously. Say, let's just think of latitude and longitude. So this is some model output from X-ray that I'm using, and you wouldn't necessarily know it because it's hidden all in this plot command, which makes it really easy, but this is a 2D plot. It's using P color mesh in the background, and it's so it's a color versus the latitude and longitude, or the X and Y coordinates in particular. So so here it is, but it looks pretty weird, right? Any thoughts about this? What's going on? Well, I haven't told you what it is either, but
Where in the world is it?
yeah, yeah, right. You don't know, do you? Here, let's scroll back up here. So one of the aspects of this model output is the dimensions are these, which you saw plotted in that plot, but we want the longitude and latitude, which are functions of the dimensions. So doing the default thing didn't work in this case because of the way the information is set up, the model output is set up. So if we go over here and plot with the longitude and the latitude specified, then get it. It's a little closer, right? Do you recognize it now? symmetrical, yeah. The aspect ratio still may be off, but it's definitely like a good part of the way there. I will briefly, these are what the model uses to do its calculations. And those are always one-dimensional coordinates. So it's just an index of the grid box in the model. But secretly kind of, because the model doesn't have to know, those map to these different latitudes and longitudes. And it makes it so you can have different grid spacing across, depending on your terrain or your domain.
Is it the name for this specific type of indexing?
Yeah, that is curvilinear coordinates. Yeah. Or you may just say 2D coordinates in a more generic sense, the coordinates that depend on both the X and the Y dimension. Okay, so when you have gridded data, worry about coordinates and also worry about color maps and projections, but we're talking about those next. Okay, so color maps. And as a moment of background, I wrote the CM Ocean package in, I guess it's in, I wrote it in Python, but it's available in a lot of other languages now, especially MATLAB. And so I have thought a lot about color maps, and so I'm going to present some of that to you and try to convince you why you should also think about color maps if you don't already. So anytime you're representing something with color, like these 3 or 4 variable plots we looked at, or the gridded plot, you should think about this. And so what does this figure show? That is the question I put. Do you know? Is it what? What? The symmetry? Where? What were you gonna say? It is blurred out. Yeah, yeah.
Elevation,
And elevation. You do get a hint, right? Because there are some numbers. There it is. So there, hey, the color map makes a big difference, right? There's still no labels besides the tick labels, but hopefully it just shows how much color and purposeful color, you know, right there at 0. Paying attention to your data set matters a lot. Okay, so color map properties. So I propose that a color, here, I'll make it bigger again. A color map should show equal changes across the data as equal changes in the color across the color map as we perceive them, as people perceive color changes. I'll show you a plot to make that more tangible in a second. Color map should be intuitive if possible. If possible, differentiate for color blindness. If it's not like a grayscale color map, which you also may want to use. And if possible, look nice. I'm also going to make the argument for being consistent so that you have like certain color maps for certain variables. Okay. Oh, and just a note that I'm not talking about categorical color maps. Like say you have, let's see, you're plotting states with a color representing the most popular food chain in that state. Those don't need to have a relationship to each other in terms of color. They just like, it's not like, you know, that McDonald's is bigger than Burger King or something if 2 different states like 2 different fast food chains. So we're just talking about valued data. Okay, so perceptually uniform color maps. And I am going to pick on JET, even though, you know, probably nobody uses it. I'm going to use it as a counterexample though, because it's nobody uses it because it's not the default anymore. It used to be the default forever. It's not now, but it's still, people do still use it, and some people purposely use it. But it's also just an an easy one to show because it's a egregious. And it's not the only one. Other color maps can have suboptimal properties. Okay, so let's start with perceptual uniformity. So I'm showing these 5 different color maps, and then I'm showing how they print in grayscale. And then I'm showing the lightness. So that's one of the 3 dimensions of the color map. A color map is a 3D representation of colors that is inherently imperfect. It can't do everything, but you can target to be good at certain things. So the one that I'm using here is maps to how humans perceive colors. And these different properties. So yeah, you can see the lightness across the color maps. You can see the perceptual changes. So that's what I was referring to with the perceptual uniformity. And then here I've plotted a cone. So this is perfectly smooth, but I've plotted it in, well, not, or a square in this case, with the different color maps, and then the colorblind version for the most common colorblindness. Okay, so just note, JET jumps around in terms of perceptual changes as you go through the color map. And I like the cone because you know it should be smooth, but it's not. And so it shows what those jumps look like in the data or in this fake data. But imagine that you have data you're trying to interpret and you plot it with something like this, you'd be like, whoa, what is going on in that cyan circle? That is the interesting thing. Or that yellow circle, that is the interesting thing. And then you're going to write your paper about that. So, oh, here, this is a little bit tongue-in-cheek, but look back at your favorite papers that use JET and see if the important feature that's being discussed is colored in yellow or cyan, because that's what stands out. Doesn't mean it's fake, but it does kind of makes you think that that's where the important thing is going on. Okay, so as opposed to having that, you can create color maps that are perceptually uniform, meaning we see these steps in the color map kind of equivalently across the color map.
Is this the ability of the eye to just from this? Is this something about perceptual change, the ability to start with color?
It's not just, yeah, the color from the color in 3D space, in the 3D color map, color space, in the 3D color space. That's what I want to say. Yeah, so it could be like in the lightness dimension only, or it could be in the other 2 dimensions. I don't go into the details here, but stepping through it in 3D space in that color space is equivalent. An equivalent perceptual jump. Sorry, did I miss something? Yeah. Hopefully that made sense.
Yeah. I thought it was a second dimension. Perceptual change.
Oh, okay. Sorry. Yeah, it's kind of floating there. Okay. And then I'd like to talk about lightness. So, and there's text down here, but I'm just going to tell you about it by scrolling back up. So lightness is this row of plots. And you can see the grayscale color map and this one, Hayline, monotonically increase. So lightness is how people understand like chunks of, we understand increments of value by lightness, or it's a good way of mapping it for people as opposed to like a change in color or something. The lightness is natural for people to understand changes in value. There's a whole research area for all of this stuff. So this is where these come from. So This is why I pull out lightness here to try to highlight it for thinking about what's your data like and should it be mapped with, well, I'm not going to make the argument you should use this, but should it be mapped with this one, this type, or this type of lightness? So these I'm going to call sequential color maps, and they should be mapped to data that's just changing up and down, doesn't have an important critical center value. So precipitation or water level, well, maybe not the water level. I'm just going to say precipitation. On the other hand, balance goes up and down, and the idea is you have some critical value that you want to compare the values on this side to the values on this side to, like an anomaly around a critical value. This one is if you have none of those things and you want, like, there's no you can think of anything with having to do with a circle is basically the time you use this. So like you want to know that like this angle is different than this angle, but this being bigger than that isn't meaningful. It's just that it's going around the circle. I'll show an example of these. Okay, so lightness, sequential color maps, diverging color maps, and cyclic color maps are how you can refer to these. All right, so which color map is better? A plot. Maybe I'll close this. A plot. Sea surface temperature, global sea surface temperature with 2 color maps. Here's one. And then here's the next here. Okay. So which do you think is more appropriate for sea surface temperature and why? The first one and why?
Because part of the, I guess, we could consider it like point, but it doesn't really, it's not effective.
Yeah, like what's going on? I would say clearly I should be paying attention to like what's going on here and these things in relationship to that. But yeah, that's artificial. I agree with you. It is really tempting to use this color map, and it happens all the time for temperature because it's so clearly cool and hot. So I do like that. But hopefully this color map has a similar, you know, cool and warmth to it to be intuitive, but without the anomaly. Yeah.
The second one, nothing.
Yes. Like temperature anomaly in particular. Oh, it'd be so good for that. Yeah. I agree. Any other comments on this that people came to people? All right. Then here is sea surface height in the Gulf of Mexico. Same question. Anyone want to speak up for their choice? Maybe pretty I really led into it. I would indeed choose the second one because we have this, it's sea surface height and 0 is important. So we want to know what's above and below 0 to understand what's going on here. This is the loop current coming in, and this is an eddy, and so it's like important to be able to pull that out really easily.
That 0, the global 0, why is it above?
I don't know. I assume it's the moment in time, but I don't know. In fact, I had a different data set earlier that I couldn't access, so I found this quick. Yeah.
There's some reason.
There is a reason, yeah. Okay, and then for tidal phase, I couldn't find my old data set that I had used before for this, and I thought it would be possibly even equally good to show an anti-example. This is from my dissertation. This is Admiralty Inlet, north of here a little bit. And I plotted phase with, I did choose a color map. I was thinking about color maps back then, but I hadn't thought about this concept of like, so right here, you know, there's a big jump in the phase that is not meaningful. It looks like there's a wall here, but it's not a meaningful thing. It's just a result of the color map alone. It should be in some sort of smooth, something smooth and lightness that would not make a big cliff there. All of these are the best. So here's your horrible warning. Don't do that.
I have a question about the grayscale.
Yeah.
So sometimes that the voice or dangerous, but you know, you like colors and stuff, but then should scientifically maybe we should be using more grayscale.
Yeah,
I don't know. I guess sometimes maybe depending on the application.
I
Is it
think
that people
grayscale-
don't use it because they want colors, but that it should be.
yeah, I think people like colors. I think grayscale wouldn't always be appropriate, right? Like here, it would not be a great choice for the sea surface height. But as a default, I do think it would be fine. Yeah, and it'd be, not all grayscales are created equal. At least I believe one time I like looked at the perceptual uniformity for the Matplotlib one, and it had MATLAB one. Well, I can't quite remember, but just keep in mind that it depends on what color space the map was made in, whether it's actually perceptually uniform or not. So it'll be decent, but it may not be like so awesome.
If you're going to print too, that all this is totally up in the air because the grayscale color map, you might be like, oh, that's gonna work better in black and white, it's gonna work better on a printer. That really depends on the printer. In the same way that colors and all. Like the delivery medium. Bucky has a whole thing about grayscale that color maps are not overused color, but you use shading, which is like it's the version of grayscale, but with color. So like better. I don't know, but one of his books is like all about that.
Yeah, I find shading difficult in practice for this sort of stuff.
Yes.
But for his plots, I think it made sense.
Yes, if you have the graphic design stuff.
Yeah, that helps. I do see shading maybe for like, you know, bathymetry maybe, if you're really trying to pull out a feature and that's important for your use. But if you're just like, I got to look at my data and then it's,
Not appropriate.
yeah, not super helpful.
His example was mostly around bathymetric maps that use this differential shading with contours.
Yeah.
I think shading can be really effective if you have multiple like variables that you're trying to show on the same sort of gradation scale, but you need different colors to different those colors. So like you have a faceted map and you have like temperature, depth, salinity, or whatever. Well, you have kind of a way to differentiate those variables without imposing, like, you're not going to do up. I mean, find another color scale to do this with. It's just pick like one color, and maybe that color is consistent across like your other plots throughout your paper if you're using that same variable, like in a different type of model. So I've seen gradation of shading scales that.
Nice. Yeah, I think it's worth exploring. As just hinted here by John, and I also would say in my next thing, I'm going to make an argument for having different color maps for different variables. So that's another reason to not just use the one. Let me stick again. Okay, so I similarly searched around and found some local data. So this is a cruise transect down the Puget Sound, taking CTD casts periodically. And I'm just going to plot it with a couple of different color maps to examine the difference. Here is a brief look at the data, but it's variables and time at different observations. So I have to show it in jet, just to get that out of the way, but I do like rainbows, so it is nice and that, but otherwise I wouldn't recommend using jet. I'll just skip ahead to the here. So using some reasonable default color map in Matplotlib, it's Viridis. In MATLAB, it's Perula, which is similar looking, but not perceptually uniform. And I don't know what it is in R. It's Viridis.
It depends on which.
Okay.
Using base or like base plot. And quite different. So if you're just like. Theories.
Okay. Okay. So this is several variables in along that transect plotted in time, and then depth here and each of the variables. So Viridis is fine for it's a sequential color map, and it's a reasonable choice for many of these variables. In fact, maybe oh, that's right. I made a temperature anomaly so that I could have an anomaly plot. So otherwise, it's a decent choice. One of the reasons that I like choosing different color maps is, like, if you look at this, you know, here dark represents the sort of water that's down here in the water column. But here yellow, or, you know, greenish blue, it represents that sort of water. But in salinity, yellow represents it. And so you're like having to train your brain to like switch colors, what you're looking for, and depending on the type of variable, which I think just like adds cognitive overload or overhead, and makes it a little harder to figure out what's going on, especially as you add more variables. And if you are plotting more than one data set, you can kind of train the reader to recognize your color map across the different data sets. And then I think it's easier to keep looking at subsequently. Let's see. And you aren't just able to like target a color map for a particular type of data. So here's what I would propose instead. Here, like, I have a color map that's chosen for temperature, like we saw before, for salinity. So you have these differences you can kind of start to recognize over time. For oxygen concentration, which I don't know if it's really appropriate here, but I went with it. In the Gulf of Mexico, this is a common problem where I was developing these. I did try to shift the color bar. So the bottom 20% is highlighted red for being low oxygen, and the top 20% for supersaturation. But I'm not an oxygen person, and but anyway, the point is that you could target, you can purposely break the perceptual uniformity for a particular purpose. In this case, if you're trying to highlight hypoxic water. Chlorophyll, got to be shades of green, right? Like, why would you miss that opportunity? And then I got temperature anomaly in here. So if you have something like that, you should really represent it with a diverging color map. So that is, that's what I think. Any questions about this or comments?
What's the number? That's just the overall average.
Yeah.
For that one cruise.
Yeah. Yeah, in fact, I used the oldest cruise there because I looked at the newest one and it had Excel files and I was like, I don't want to deal with that. But the older ones, you have CSV files, so I use that. Okay, I didn't talk too much about color blindness, but you can see it in that plot, and there are online tools for changing your plot to see what it would look like for different kinds of color blindness. And that's worth doing, but generally, if you avoid red and green in the same plot, that's helpful.
So we have one or the other.
Yeah.
Well, that's,
Okay. One last topic, projections. I didn't know if people would have already thought about these or not. People thought about projections before? Can you raise your hand if you have thought about projections? Okay, so I'm gonna go through this really fast then, because it sounds like everyone has thought about it. The base problem being we live on a spherical Earth, and that doesn't, in a straightforward way, map onto being flat. And so we have different projections to account for that. They each are imperfect in different ways and are good in different ways. So I have a little bit of wordage here about how to choose. Like you could preserve distance or angles or area, for example. Otherwise, I just wanted to show an example of making a plot respecting the projection, and being able, in particular, being able to add other information like a map or a coastline, other stuff that probably matters if you're thinking about the Earth. I started from an old Epic plot script that's here. You can see it, it's really long. And the animation that it produced, I pared it way down, and I'm gonna just close that. But here's the plot. So it's the same data or same model output we saw before, but now I used a particular library, Cartopy, to plot it on the Earth. And the points being that you can label the latitude and longitude, you can, the aspect ratio should be appropriate to your projection. You can add land, political boundaries, etc., to give that important context for your Earth-based plot. But depending on what tool you're using, you have to probably think about the projection and make sure you're plotting in the appropriate projection. If we were going through this, that would be like, we'd have to talk about it in Cartopy for a while. And then in terms of an interactive plot, I just brought in HV plot here. It's pretty easy to append on with these Panda's data frame or an X-array data set. So it's an easy one to use if you are in the Python world. And it's, you can stick it in there. It's a quad mesh because it's this gridded model output I was referring to before. And in this case, you can just say, tiles to get the map in the background and inform it that it's on the map and the projection, and it will do the rest for you. I'm not sure if this is still active or not, but you can zoom in and everything on there. Okay. Oh, I have one more thing. Miscellaneous tips. Oh, but this is it's pretty fun too. If you haven't used HV plot, I encourage you, if you're in the Python world, to take a look at it. It's pretty cool. Let me just end with a couple miscellaneous tips. Most of this I have said, but if you're doing an animation, make sure you set your color bar range fixed so that different times can be compared to each other and the color bar doesn't jump around. That's really annoying. Don't try to do too much on one plot because it can be overwhelming, but do enough so it's useful. You know, if you don't give enough context, then the viewer will be sitting there thinking like, well, what about this? What's the relationship there? Or put it in the plot next to it. Try to make your plots obvious and intuitive. Like the fewer questions they have to ask, the better. Like the less they have to read the caption. If you can kind of get it in there, it's better. And I also wanted to address one thing people don't like about perceptually uniform color maps is because they don't have these big jumps built into them, it's, it's smoothly varying. So if you actually want to like read, kind of know what that value is right there, it's harder to read off. So here are a couple ideas for that. You can add labeled contours over the top to give some idea for the viewer. You can use a discrete color map instead of continuous. So you break up the color bar into like 10 sections, and then you can kind of read off which section it is in of the color bar. You lose some information, but you gain that ability to read the numbers. Or if you use an interactive plot like here, what was there? I don't know if I had, oh yeah, I did have, I feel like I've like kind of lost my, okay. I'm not gonna do it because I haven't rerun the data, so. But there's a hover and it shows the salinity value there. And so that's another nice way if you're doing something that you can use in interactive mode. Okay, I'm gonna stop there. And then we can have questions or discussion or talk about your plots. What do you guys think? Oh, yeah.
It's by user group, so I have two questions.
Yeah.
One is that, you have like instead of having a 3 diamond. Like for
Yeah.
example, I was doing like offshore of California and then the topographic it's there to me. And then I would love to show, okay, there's a seamount there and then there's like a unique features for that. So I tried to make a 3-dimensional plots of it. So like I kind of tried a lot of different kind of methods or package, but nothing like really easy to get hands on and or make the plot like easy enough for me to do it in 2 days, but it's 2 months. So and that experience. And the second questions would be, I see those people making like really pretty plots, like there's like several like subplots with that. But there's like not in a really regular subplot, like 2x1 or 2x2. It's more like, oh, this is like rectangular one. One is like is the global wheel of the data set. Like, is there a package or a, like visualization way to have this pretty plots?
Okay. I am not a big fan of 3D plots personally. And it could be, I don't know, maybe I'm old fashioned now or something, but I haven't seen them where they're very easy to understand. Maybe if they're interactive, so you can actually drag it yourself, then it can be okay, I think, because you can kind of figure it out as you drag around and find a good angle. But I haven't found it to be you certainly can't just plot it. And I haven't found it to be worth the effort when I've tried before. I would prefer to do cross sections, basically 2D plots, but like strategically trying to capture what you're seeing. But some people do, there are packages to do it, and some people either need it or like it. I'm not sure which. So I don't have good advice about 3D plots, I'll say.
When it's interactive, it's much better.
Yeah.
So for data exploration, it's great. And I can also be like, do the data exploration. Python has a couple of packages we can talk about offline, but I like to use them to figure out what I'm trying to see.
Okay.
And then when I see it, then I want to see a cross section.
But then do you have
oh,
to-
I want to put the cross section right there.
But you have to choose like which surface level to plot in the first place, or like how do you even?
The way I do data exploration often is to do it by just 3D scatter, and so then you get a point cloud and spin it
Oh, I see.
around and see some of the structure, and then you can color those points, right? So you can kind of do the same things you do in a 2D scatter plot, in a 3D scatter plot to do data exploration. But it's hard to make that into a figure that would sit in the paper. So that's why I think a lot of
Yeah.
people do that.
Yeah, the current is one of the things like, okay, Google Earth is like the best, like really good, the seamount somewhere, and then, but it's hard to like get your the temperature or like wave data get into Google Earth.
in a way that looks.
Yeah,
good.
it's just like, I have the best Google Earth, I have the best data, but how do they combine that?
There is the HV plot package, is run mostly with this thing called Bokeh, which is the data plotting stuff. And that's one of the ones that makes the dashboard better. Again, for the data exploration. I don't know if you say that at all.
Yeah, usually not, usually through the other thing, HV plot or panel.
Yeah.
I find it confusing directly.
It is very. But there are some
That's a good
ways
idea.
that are
Yeah.
fairly straightforward to link those plots together.
Mhm.
And then again, in the data exploration realm, that becomes really powerful. Because you can highlight these points and see where they show up. In the plot. If you're looking for the relationship.
Thanks, yeah, that's
But you
good.
can burn up more than 2 months.
Yeah. As for your other question about the subplots, I think what you're saying is like, it's not like 1, 1, 1, 1. It's like maybe 2 plots on the top, 3 plots on the bottom, different arrangements. Yeah, I mean, Matplotlib, I think many plotting libraries can do it. In my experience, what's difficult is figuring out the detail. But you can choose everything. And again, I think like AI assistance tools probably make that a lot easier now. Rather than like you trying to figure out which thing is appropriate.
Have you like, kind of a situation like, for example, about 2-dimensional plot, like in certain depth, like for example, temperature in like depth is 10 meters. And then can I tip it a little bit and then get additional layers of something on top of it, like, it's more like a, again, it's a 3D plot again, but,
Slices.
yeah, but it's like. Is it also doable in Matplotlib, or is it something else?
I don't think so. I don't do anybody else. It makes me think of a waterfall plot, but I mean,
Makes me think that some of these we learn it's easier to make that to make the plotting Matplotlib separately and start them in PowerPoint. And then you can have way more, like slices and stuff. So at some point it's easier to do the part in PowerPoint. Once you do the separate plots. Of course, they shouldn't be long, but they should be correct blocks. Yeah.
You can do anything in that level. It's just like taking what they're going back to that. But any, any
another cool thing I've done for, when you have limited space, because you have your 10 figures in your paper or whatever, do a plot and then have a magnification of a certain area. That's kind of cool, Matplotlib. And it takes so much time, but it used to at least take so much time to tweak everything to make sure it's visible and everything. But if you only have, your 10 plots, then you gotta make the most of your space. Is it related to that? Oh, yeah.
Your color map, like absolute. So you have that big out block of the both next to it. See all the variation, but then you want to do that on small. There might not be. You won't be able to see that variation. Color map down. So in that situation, introduce some color map.
Yeah, you could do that.
No, not just
Oh, I mean, you could do the magnification and actually have a different color bar for that area. But yeah, if all of the suggestions I talked about for color bars and color maps, if you have a reason to do it differently and it's, you've thought about it, you should, that's fine. But these are like, if you don't have a good, like the red and the yellow and the oxygen color map, those were like breaking the rules, but for a good reason.
You can also contour on top of it. Like you're zooming in and it's color. Contour over top of that. At that scale, the contour is not be able to see the difference. Or zoomed out, it's just like black.
Yeah, that's good. John.
Yeah, I was just gonna say that there's a package of password that lets you do something that's like non-standard, like massive type plots. very similar to that with Python as well. I'm not as familiar with Python, so yeah, I'm assuming that probably like the steps it takes to get to that point are probably pretty complex. For everything else and stuff like that. But, yeah, there might be another package, but yeah, that probably affects some thought.
And then now they have example for that.
Thanks. Do we need to stop right now or should we finish questions? No?
I just got a question for the first one staff. If you use RTAS with your access to TAS, they're really good at layering data. So you might not use it for your final pop, but you might not understand. You can then have all the layering and you can uncheck like the one just above the one you're looking at, and if you really go to the layers. So if you really do that paper, but you can understand.
Thanks.
Yeah, I'll just ask for, the HV plot suite. I think for some X-ray, you have several layers, they automatically make the interactive plot that you can click on the layers. Change them to something like plotting it is gonna detect that text channel as an extra layer. So it's kind of nice. It's both making a widget, which, you know,
Good suggestions. If you're making a new thing, Google first. Like somebody's probably done it before. It's not always straightforward in Matplotlib, but it has gotten a lot easier and maybe see if somebody's already made a package that makes that easier for you.